Hello, and welcome to the tutorial number 1 of our brand new Godot tutorial series, where we'll be learning how to make a fully responsive 2D water. This system is made using basic physics, and the concept could be applied to other engines or languages. It has all sorts of parameters, and you can customize it however you wish. I also made a demo on itch you can use to see how each parameter influences the simulation. All the files, the source code, and a link to the demo are available in the description. Now, before implementing it, I will first explain how everything works, but if you really want to jump straight into implementation in Godot, then go to this time in the video. So first of all, how does it work? First, imagine you have a simple spring which is being extended and held in a height position. As you know, springs have a natural position, and the springs always tries to return to this position. Let's call it target height. To make things simpler, let's call this distance x, which is how much we extend the spring. What dictates how our spring behaves is the Hooke's law. F is the force that makes the spring return to the natural position. K is the stiffness constant of the spring. And X is how much we have extended the spring. By applying this force to our velocity vector on each frame, we will have this result. The spring always tries to return to the target height, but since the spring overshoots its destination, we end up with a wave. To make the wave stop, we will add a loss factor to our wave, which will be dependent on our spring velocity v and the spring factor d, also known as damping. By adding this loss to our Hooke's law equation, our wave will have this behavior and actually stop. To make it look like water, we need more than one spring. At our current state, they don't affect each other, but we do need them to affect their neighbors. For example, if the spring number 3 moves by a large amount, we need springs 2 and 4 to move by a fraction of that amount, which in turn move the waves 1 and 5 by a fraction of that amount as well. The result will be that every spring will pull each other, and we will have a nice responsive wave effect. This brings us to the third step, which is to simply draw a polygon using those points, making it an actual body of water. This is looking pretty good already, but we can do better. By using the magic of splines, we will make a nice smooth border around our water body, and then make some particles to finish it. So, let's get into actually implementing it in Godot. In a brand new project, create a new 2D node for the main scene. We will call it main. If you want to use the exact same settings as I am, go to Projects, Project Settings, and then under the Window tab, those are the settings for width, height, test width, and test height I'm using. I also set the stretch mode to 2D and the stretch aspect ratio to keep. Then, create a new scene and make it a node 2D. This will be our spring scene, which we will call water spring. Just so we see what we are doing, attach a sprite node to the water spring and put the joint.png image to the texture field. Save the water spring scene and then put an instance of it in the main scene so we can test it properly. Back to the water spring scene, attach a new script to its root node. First, we will declare some variables. We will need a velocity variable which we will set to 0. Then, a force variable also equals to 0. We will also need a height variable which is equal to our position.y. And also our target height variable. We'll set it to position.y plus 80 for testing purposes. Lastly, we will need our spring stiffness constant, which we will set to 0.015. We will now create a function called waterUpdate, which will be responsible for applying the Hooks equation into our spring in each frame. We will set the spring constant k as one of its arguments. Inside the function, we update our height value to our current position.y, since the position will move at each frame. Then, we declare our spring extension, which is the difference between height and target height. Then, we calculate the force applied to the spring using Hooke's law, which is minus the spring extension x multiplied by the spring constant k. Now, we add the force to our velocity variable. And finally, increment our position.y based on this velocity. In a physics process function, we simply call a waterUpdate function, and if everything was made correctly, we should have our water spring moving up and down. Now, we will add loss to our system to make the wave stop. We will declare one more variable, which is our dampening value. We will then add the dampening as an argument to our waterUpdate function. We will then declare our loss variable, which is equal to minus dampening times velocity. Add the loss to our force, and the wave should stop now. Our spring modeling is basically done. Now, we will create a new scene, which will be our actual body of water. For now, we will manually put 5 water springs instances on it. Save our water body scene and put it in the main node. Attach a new script to the water body scene. In the script, we will first declare the spring stiffness constant k and the dampening value d. We will also declare a spread variable. Now, we will declare our spring array, making it empty. In the ready function, we will loop through our children. Inside the loop, we append the I variable to the springs array. This will basically fill the array with the springs. Still inside the loop, call this initialize function to each of our springs. Back to the spring script, create the initialize function. Inside this function, make height equals to position.y, target height equals to position.y as well, and velocity equals to 0. This will make sure all the springs are initialized correctly. You can also set height and target height both to 0 and delete k and d. Also, be sure to delete the physics process function of our spring. Back to the water body script, we will make a physics process function to update our array of springs. Loop through the array using a for loop and call the waterUpdate functions. Declare 2 more arrays, which we will call left deltas and right deltas. The left deltas array will store the difference in height between each spring and its left neighbor. The right deltas array will store the difference in height between each spring and its right neighbor. Make a for loop with the size of our springs vector, and in each iteration, we will append a 0 to our left deltas and right deltas arrays. Now make a for loop with the size of our spring array. We will make an if statement, I greater than 0. Inside of it, we will calculate our left delta values. As I said before, left deltas store the difference in height between a spring and its left neighbor, multiplied by a spread constant. Now, we can use this value to increment the velocity of our left neighbor. Since we can't have arrays with indexes greater than the array size, we'll check if I is less than spring size minus 1. As before, the right deltas will be the difference in height between a spring and its right neighbor. Then, use this value to increment the velocity of our right neighbor. Now we can finally make our wave move. Add a new function called splash. It will receive the index of the spring we want to move and the speed value as its arguments. Make an if statement to make sure the index is inside the boundaries of the array. If it is, then get the spring with that index and then add velocity to it. If we call this from the ready function, like so, we should see the springs move like a wave. What we want is the whole body of water to move in the same frame we created the wave. To make that, we will declare another variable called passes, which is how much this process is repeated every frame. Then, get this whole for loop in which we calculated the wave spread and put everything inside another for loop with the size of our passes variable. Now our wave spreads much faster. Go to your water body scene and delete the water spring instances. In your water body script, declare a variable called distance between springs. Also declare a spring number variable. We will also reference our water spring scene. Now go to the for loop in our ready function. Make the for loop the size of our spring number and delete what is inside of the loop. Then declare a variable called xPosition. This will be the position.x of each spring in the array. We'll also make a variable called w, which is an instance of our water spring scene. Add this w to the scene. Append the new instance to our spring array. Then initialize it again, but this time put the xPosition as our argument. Now go to the water spring initialize function and then add the xPosition as one of its arguments. And inside the function, make the position.x equals to xPosition. Now, into your water body scene, you can change the distance between springs variable and the spring number variable as you wish. Now, we will draw our water body polygon. Go to the water body scene and add a child node to it. Make this child a polygon 2D and hit create. We will call it water polygon. In the water body script, we will need a depth value, then a target height value, which is equal to global position.y. Also, a variable that will hold the bottom position of our water body. Lastly, we'll make a reference to our water polygon node. We'll create a new function called drawWaterBody. First, declare an array called surface points. This array will hold the positions of our springs. Then make a for loop with the size of our springs array and append the spring positions to these surface points. Then declare two more variables which will hold the first and last indexes of our surface points. Now declare a new water polygon points variable which will store all the points of the polygon and make it equal to the surface points. To enclose our polygon, we will need two more points at the bottom of our polygon. First, add the point to the very right and very bottom, like so. Then, add the point to the very left and very bottom as well. We will convert our newly formed array to a pool vector 2 array, like so. Then, we just set the polygon of our water polygon node to this new variable. With this done, our water body should be formed. This is how it looks for now. A little too square for me, but we will smooth it out soon. If you change the color of our polygon via inspector, it will look washed out. Just so we see how the transparency looks, I made a little background and put it into the main scene. It doesn't look right, it needs more saturation. In that case, we use a simple shader to make it work. To make the shader, we'll instance a new scene into the main node. It will be a color rect node. With this color rect selected, go to the inspector and under the visibility tab, select material and then select a new shader material. Under shader, select new shader. Be sure to save your shader. Now, click on the shader to open it. First, let's declare the shader type as canvas item. Now let's declare a uniform vector 4, which we will call tint. Let's give it a hint color and let's make it equal to vec4 1.0. We will blend this color to our background color, so make it blue. Create a new fragment function. Inside the function, make a new vec4 variable called color. Color will call a texture function with screen texture and screen UV as its arguments. This will map the screen textures to the screen coordinates, so if we assign the color like so, it should go transparent. Now, we will mix the transparent color to our tint color using the mix function. The last argument is how much the second argument is mixed with the first one. You can play with this value to make it more transparent or more opaque. Now we will make another mix. We will mix a vec4 0.5 to our current color. Vec4 0.5 is a gray color which should not change our water tone. By mixing it with a value greater than 1, we're essentially making the color of our screen stronger. Save your shader. You can delete the color rect now. Click on your water polygon node. Now add the shader material as we did previously. Drag and drop our new shader into the shader tab. So that's how it looks at the moment. Now let's make a nice smooth border. After some research, I found this page about drawing curves in 2D, where a very nice person by the name of D-Lean Jeans made a curve spline tool using Path2D nodes. We will be using this script to make our water smoother. With our new script in hand, go back to the water body scene and then make a new child. Look for a smooth path and hit create. Under canvas item, visibility, the self-modulate is probably blue and transparent. Make sure it is plain white. Rename it and then enter the water body script. We will declare a new reference and also a border thickness variable. In the ready function, set the border width to the thickness value. Now create a function called newBorder, which will be called each frame. Declare a new curve variable that will hold a new curve2D node and make a new surface points array. Then, add those points to our curve with another loop. Then, we just need to assign our new curve to the border curve. Call the smooth function inside our border, and then call the update function of our border. With that, our water should have a nice smooth line. If we look closely though, we will see that even if our line is curved, our polygon is not. Let's fix that. Go to your draw water body function and delete the surface points part. Make a reference to our curve and then a new points variable. This variable is going to get the points of that curve and make an array of them. Change the location of your polygon points variable like so and make it equal to your new points variable. Then change where it says surface points to water polygon points. And now the polygon should also follow the curve. We're almost finished. We just need a way to make our scenes interact with our water. We will use a stone object to interact with our water object. Since this is not the focus of the video, I will just quickly go through it. Our stone is just a kinematic body 2D with a sprite attached to it and a collision shape 2D with a rectangular shape. This is the stone script, which just makes the stone fall. I also attached a script to the main scene. It will spawn stones at my mouse position. Go to your water spring object and add an Area 2D node. Then add a collision shape 2D as a child with a rectangle shape 2D shape. Make a reference to the collision shape 2D. Then make a new function which we will call setCollisionWidth. It receives an argument called value. Inside this function, make an extents variable which will hold the extents of our collision shape. Then declare a new extents value. This will be a vector2 variable in which x is the value divided by 2 and y is the extents.y. Then set the extents of the collision to the new extents variable. Back to the water body script, call this function from the loop in the ready function, like so. When testing it, the collision of the springs should fill the whole water surface. Into your spring scene, select your Area 2D and under the Node tab, select Signals. Right-click on the body entered signal and connect it to your spring. This should detect when something hits a spring. Inside the spring script, declare an index variable which will be set to 0. Also make a motion factor variable. This is how much an object affects the water. Lastly, declare a new custom signal called Splash. On your Area 2D body entered function, make a speed variable equal to body.motion.y multiplied by the motion factor. This body.motion.y is the speed of your body. In my stone code, I called it motion. Then emit your splash signal and pass index and speed as its arguments. Under your water spring initialize function, put the index as an argument as well. Add the same thing to the water body script. And lastly, connect our water spring splash signal to our splash function, like so. Now our stones should be interacting with our water body. It looks a little weird though, since sometimes the stones collide with the water springs more than once. There are a lot of ways to fix that, such as using timers. I'll simply not let the objects collide with the water more than once. Add a ColliderWidth variable to our water spring. This variable will hold the last objects we collided with. In the Area 2D body entered function, make an if statement so if the body is the same of what we just collided, then just return. If not, then assign the body to the ColliderWidth variable. Now it should work properly. There are cases where you want something to happen to the player in the case he enters the water, like reduced gravity or state changing. Go to your water body scene and then create a new Area 2D node with a collision shape 2D. Make references to both of them in the water body script. In your ready function, declare a new variable which represents the water length. Declare a new rectangle variable which will hold a new rectangle 2D node. Then declare a rectangle position variable. This will be in the very center of our area. The rectangle extents are the same value. Then assign the position and extents to our area and collision shapes. Now we have an Area 2D which covers all of our water body. If you select your area, go to Nodes, Signals, and then connect your body entered signal to your script, you'll be able to detect when something enters the water. With that in mind, I'll leave the particle creation as a homework. Of course, the complete project will be made available to you. At this point, Feel free to play with your water to see what results you get. One more thing before we finish. If you make your distance between springs too small, you may see some polygon flickering. To fix that, go to your water body scene and click on your border. There, you should see a variable called spline length. If the distance between springs is too small, make sure to make this smaller as well. I really do hope you enjoyed this video. Making this tutorial took me longer than expected, so I could not make a devlog this week. It should be going back to normal soon though. If you like this kind of tutorial videos, don't forget to like it so I know I should be making more. That's all from me, and cheers!